All right, so now we move on to lesson 4 of equations, and lesson 4 of equations is complex fractions. So complex fractions, in comparison to what we've done before, well, even looking at the first couple examples, I'm going to draw our attention to the sharp difference between a complex fraction and just a standard fraction that we would have dealt with in lesson 3. Well, if we look at example A here, what we'll notice is that there's actually a binomial in the numerator. And in example C, there's a binomial in the numerator. Whereas if we go back, let's say we go back to some of our practice examples, say from our first check your understanding section. Lesson 3 was all about what if I just have a simple fraction like a monomial over a monomial over a monomial, and solve it that way. Now, the nice thing is the approach is actually the same thing. If we go back to our lesson 4 here, the approach to solve these is identical. We're going to take every term and multiply it by an LCM of the denominators. We're going to expand the brackets, combine like terms, isolate the term with the variable, and then divide every term by the multiple on that coefficient. So let's see how this works in a couple examples here. In the below, I know my LCM is actually 4 because it's the only number available, so it must be the one they have in common here. So my LCM is equal to 4. Now, from our previous lesson, when we found our LCM, we multiply it to both sides. So I take my LCM, I surround everything on the left and right in brackets, and then I multiply. When I multiply this, it's going to eliminate the 4 over 4, because 4 divided by 4 is 1. And then when I multiply 4 to the next brackets, well, same thing, because I have a multiple of 4, I can eliminate this to 1 over 1. Now, my next line looks like 1 is equal to x plus 1. Now, my whole goal is to isolate the variable. So in order to do that at this point, I just need to subtract away the number being added to this x. Therefore, 0 is equal to x. Or, as we know, we can write it the other way. X is equal to 0. All right, let's go on to example B. Similar concept here. We see an LCM is actually already there because it's whatever number is just currently there. An LCM is equal to just 3 because they both share that common denominator of 3. So their lowest common multiple must be 3. Now, I'm going to multiply my left and right hand sides all by 3. When I do that, similar to last problem, I can cancel out my 3's, and I can cancel out my 3's being multiplied, and therefore I would get 2x minus 4 is equal to 2. Now, there's a number being subtracted from my x's, so what I have to do is I have to add the 4 and add the 4 to both sides, giving me 2x is equal to 6. Finally, I have some number multiplied to x, therefore I must divide by that same number, thus giving me an x value of 6 divided by 2, which is 3. All right, let's go down to example C here. So now we're not just automatically given an LCM. We're going to have to figure this out. How do we get an LCM? Well, it's the first number that both of them multiply to. So when I look at 6 and 2, well, I would realize if I multiply 2 by 3, I can get to 6. So we know that the LCM between 6 and 2 would be LCM is equal to 6. So now, if I multiply both sides by 6, here's what happens. Make sure to surround everything on the left in brackets, everything on the right in brackets, and multiply. If I multiply 6 over 6 in the first bracket, those eliminate to 6 over 6, which is 1. And 6 over 2 on the right-hand side eliminates down to 3, because 6 divided by 2 is 3. Now, I have 4x plus 5 is equal to 7 times 3. Therefore, 4x plus 5 is equal to 7 times 3, which is 21. Now, I need to subtract away this 5 being added to the variable. That leaves me with 4x is equal to 16. And then finally, I have a number being multiplied to the x, so what must I do? Divide by that number. And so, therefore, we should get an x value of 16 divided by 4, which is 4. Okay, now, I have multiple fractions on the left and only one number on the right. Same approach that we do here. Remember, if I am trying to find an LCM here and I have two numbers, well, if it's not obvious to me right away, like in the last example where I knew 2 could multiply to make 6, what would the LCM of 5 and 2 be? A really simple way to get your LCM is to say, what if I just multiply those two numbers together? So I can say that the LCM is equal to 5 times 2, and 5 times 2 would give me an LCM of 10. That is the first number that both 5 and 2 multiply to. So if one of the numbers is not just simply a multiple of the other, this is how we can find our LCM. Just multiply your two numbers together. Now, remember, we have to surround everything on each side in brackets and put 10 around it. So whether you want to do it individually and put times 10, or you want to surround it by the entire bracket, we know it will do the same thing. Because in this case, what we're going to do is we're going to distribute this 10, but we could have just multiplied it to each of those terms, and that would equally be as fine. So if I multiply 10 to both these terms, well, 10 divided by 5 reduces down to 2. We have 10 divided by 2, which reduces down to 5 in the second fraction. And then 2 times 10 would be 20. So if I go to my next line here, I should have 2 times the x minus 3, which is the binomial, minus 5 times the x minus 4. Because when I reduced my terms here, when I did 10 divided by 5, the answer of the coefficient was 2. When I did 10 divided by 2, the coefficient remaining was 5. Now, this is all equal to 20, or 2 times 10. Now, I need to expand these brackets by distributing my terms. So in my first bracket, it becomes 2x. 2 times a negative 3 is negative 6. Negative 5 times x is negative 5x. And then negative 5 times a negative 4 is positive 20 is equal to 20. Remember, here's a key thing. From polynomials, we knew when we had this negative coefficient, it changed both the signs on the interior. So did it not change the signs? Well, yes, it did, because we had a negative and then it became a negative x. We had a negative, and when it got multiplied to the negative here, it became a positive. Okay, now we got to combine our like terms here. So I have 2x minus 5x is negative 3x. I have 20 minus 6 is going to be positive 14. This is equal to 20. Now, what I could do here is I could move my negative x's across to the right-hand side and then move my 20 across. So maybe I'll show the two methods, one in red and one in the other way. So if I want to show one method here, I could add my x's to the other side and be left with 14 is equal to 20 plus 3x. I could subtract away the 20 from both sides and therefore have negative 6 is equal to 3x, where I divide the 3, and therefore I get an x value, x being equal to negative 2. The other way I could do it is, instead of moving the x to the other side, what if I just left the x exactly where it was and then divided that negative at the end? So let's just shorten this line here. We'll draw it over this way. Perfect, okay. So instead, I'm going to leave the negative x where it's at, negative 3x. I'm going to move the 14 to the right side instead, which means I have 20 minus 14. That's equal to 6. And then at this point, I need to divide by the negative 3, because I never want to have a negative x value. Therefore, I get x is equal to 6 divided by negative 3, which is negative 2. So there's a couple ways to approach this. Just know that if your variable is negative, you just need to divide by that negative in the end. All right, and now let's work on the u-try section. So the u-try section should look very similar to the ones we did above, where A looks very similar to our first two, and then B is going to look very similar to our last example, or the last two. So let's solve A here together. If I want to solve this, I realize that my LCM is going to be equal to 4. Reason being is because I can multiply 2 by 2 to get 4. So the first number that both these reach is an LCM of 4. Now we know the LCM must be multiplied to both the left and right side. And so when I multiply both the left and right, 4 divided by 4 eliminates to 1. 4 divided by 2 eliminates to 2. So then, therefore, I have 2x plus 10 is equal to 7 times 2, which is 14. I have some number attached to x through addition, so I'm going to subtract it from both sides. So now I have 2x is equal to 14 minus 10, which is 4. And now I just must divide by that 2 being multiplied to the x value. Therefore, my x is equal to 4 divided by 2, which is 2. All right, let's move on to b here. B has multiple terms on the left, just like some of our later examples in the notes. So what we're going to do is we have to figure out the LCM. Remember, if the LCM is not obvious right away, we have a 3, a 2, and a 3. What is the first number that both of these multiply to? An easy way to find it is to say, I'm going to take one of each of those terms and say that my LCM is equal to whatever they multiply to. 3 times 2. That's equal to 6. And we should know this from number sense. Number sense always said that we take one of each of the values, or one of each of them, the smallest, and then multiply them together in order to get our LCM, or lowest common multiple. Now, I multiply both sides of this by the value of 6. So I go 6, 6, there we go. Now, I'm going to go term by term and see what this multiplies to, considering the denominator. So if I go 6 divided by 3, 6 divided by 3 is equal to 2. 6 divided by 2 is equal to 3, which will be the coefficient of our second binomial. And then we go 6 divided by 3 is 2. So now, let me rewrite this out with all their new coefficients. This becomes 2 times x plus 5 plus 3 times x minus 3 is equal to 2 times 13. Now, if I distribute my brackets here, I'm going to take each of the coefficients and multiply them through. So I take each of the coefficients and multiply them into the given term. This becomes 2x. 2 times 5 is plus 10. 3 times x is plus 3x. 3 times a negative 3 is negative 9, is equal to 2 times 13, which is 26. So my whole goal on the left-hand side now is to combine the like terms. My like terms are 2x plus 3x, which is equal to 5x. And then I have 10 minus 9, which is plus 1, is equal to 26. Now, I have some number being added to my x term, so I have to subtract it off both of the terms. This gives me 5x is equal to 25. And then, like always, our last step is to always divide by whatever coefficient is attached to x. Therefore, my x value here is equal to 25 divided by 5, which is 5. All right, so from here, I would like you to check your understanding. There's one page of check your understanding because it is very similar to lesson 3, but I want you to do every example here because as we see, there's one fraction, with a binomial. As we go later in the examples, you're going to see 2 fractions with binomials and how do you handle those ones. So please make sure you're doing the entire page for your check your understanding.